Good morning, students. Welcome to Neet Care. So, my name is Chaitanya. Here I am going to take physics classes. And this session is for those who are very seriously preparing for NEET 2025. Especially who took the drop this year and aiming a decent rank in 2025. So before entering into the class, guys, let us discuss something about Neet Care organization. So Neet Care is the academy almost running from past 10 years, where the success rate is almost 90 plus percentage. Means those who took coaching from our institute, almost 9 out of 10 got placed in various medical colleges. And for more details, you can visit anytime our campus in NARAYANAGUDA. Right, in this session, the main motto is to boost confidence in NEET physics. Usually, for majority of the students who are preparing for NEET, physics going to be some kind of challenging one, or sometimes physics mark going to be a rank deciding also. You guys know that very well, right? Here the orientation sessions. So these are orientation sessions followed by chemistry class also. The main motto of orientation session is to boost confidence on the subject. Myself is Chaitanya. I'm going to take care of complete physics classes in the Neet Care. And another one of my colleague and friend, Rajesh sir, is going to take care of chemistry. Next follows his class, right? So now, in this orientation sessions, approximately 2 to 3 weeks is going to happen. In the next 2 to 3 weeks, if you continuously follow the every session, I'm 100% confident that anyone who are not even comfortable with basics in physics also can start loving physics. That kind of planning has been done in this orientation sessions, right? Means, listen students, if you take previous 3 years or 5 years, anything, majority of questions, even you take the recent 2024 also, majority of questions in physics, not only in physics, entire paper. In NEET 2024, majority are from easy to moderate. Even I can't say difficult also. Many questions were directly given from NCERT. But even then also, the question is why people are lagging in cracking this subject, right? By keeping all these hurdles, obstacles, and phobias regarding the subject, we have planned orientation session before starting the batch. And most of these classes are meant for, already I told, those who took drop, like those who are planning for long-term sessions, right? Since the people who are planning for long term or taking drop, definitely you will be having some basic idea about the subject, no? You might have at least studied some theoretical information about the subject. That's why in this session most of the focus will be only on application part, because guys, physics is a kind of subject where I always strongly believe that only 1% will be the theory, 99% will be the practice and application. 99% application which can be developed through practice. Practice is only the source to get strengthened in physics. But most of the guys, they will be having a misconception that if you are really excel in theory, if you are very good in theory, then you are going to excel in the numericals. But this is totally misconception, students. Of course, theory is very important, I agree, but only with the help of theory, especially in physics, you can't manage numericals. You need to do lot of practice, and you need to manage time, and you need to develop the accuracy also. So now guys, this session is totally going to focus on the practical analysis of the physics. Means how to start preparing, especially kind of high weightage topics. High weightage means there are some areas, guys, very constantly most of the questions are coming. For example, electrostatics is there. See, in the recent 2024, many questions appeared from capacitors, and even you take 3-4 years analysis also, it is a consistent chapter where we can expect 3 to 4 questions compulsory under any worst case. So in that kind of high weightage topics, how to start revise, from where you need to start, and what kind of problems need to be solved, that all you must have idea and awareness. Every student will start revising traditionally right from introduction. Of course, you need to do that one only during learning process, guys. But the moment when you start revising and the moment when you start practicing, you have to come in a specific order where you will be where you need to focus more and more to crack the question, right? So starting from where you need to start is very, very important. And in this orientation sessions, guys, I'm going to give you some basic information about how to begin some specific chapters, right? What kind of start you have to do, some specific areas. Because guys, you take electricity. I'll give you the example, then we will begin our session. Many people will start going electricity with the definition of electric current, drift velocity, and Ohm's law, resistors. Of course, that is the order. But what I strongly believe is, if you are okay with the theory, not even good enough, if you are okay with the theory, theoretical, if you are really okay, then I strongly suggest you to do electricity by solving circuit problems. And after that, I'll suggest you to do the problems on heating effects in the second priority. And then I will strongly suggest you to do then resistance. And after that, your choice. So for a specific chapter, guys, after learning the theory, no need of doing revising every time from starting. You need to take some areas where interesting part will be there, as well as relatively high weightage, because I never seen the paper in the past 6-7 years in the Neet without a circuit problem. 100% circuit problem will come. So such kind of areas you need to select, and you need to focus, or you need to keep some extra energy on it. So every chapter will be having some core areas from where you need to begin practice, not learning, right? But since you are almost here, attending students are long-term students or droppers, definitely you might be having some idea on the theory. That's why the starting is very, very important. So now, guys, as a part of our session, now I want to take kinematics. which is familiar to you right from schooling, is it or not? And in this kinematics, I'm going to begin with motion in a straight line. This is. And if you see 3, 4, 5 years analysis, consistently 2, 3 questions are coming from motion in a straight line. One direct question, one indirect. Sometimes both are coming direct questions only. So relatively after units and measurement, high weightage topic is this one, motion in a straight line, and cracking the question is also not much challenging part. You can crack question easily here if you practice in a specific order. Instead of going the traditional method, means right from revising kinematic equations, definitions, that all should be done only during the learning part, like distance, displacement, that all. But when you start practicing, you need to select some areas, especially from where questions are very frequently asking. Such area should be selected, right? So in motion in a straight line, say guys, of course, every subtopic in motion in a straight line have equal importance. Whether you take horizontal motion or vertical motion, importance is equal, right? And coming to here in today's session, I am going to focus some on motion under gravity. Specifically, why I'm taking motion under gravity here is, which looks simple for many students. Even in the classroom, if I ask the students, like how many of you are not confident here regarding to motion under gravity, means I don't find no one raising the hand. The reason is, right from schooling you are familiar, and most of the information related, theoretical information will be related to kinematic equations. So V equal U plus AT, that all kinematic equation, that you are familiar. But coming to numericals, many students will attempt question from in this area, but unfortunately many will lose the marks by committing some simple and silly mistakes. Sometimes in the calculation, sometimes in the applying the concept itself, right? So focus on this motion under gravity, right? So listen guys, let us see some important information related to motion under gravity. After that, some problem solving logics we'll discuss. So listen, as far as motion under gravity is concerned, first you need to understand sign convention, which is very crucial. Here, understanding sign convention is very crucial, because of which many students will lose the marks. Usually, start right. Motion of gravity, sign convention, right. Now I am entering the topic, guys. If you want, you can note down the important areas, because here I am going to share only the information that will help you to solve the numericals. So coming to the sign convention, for freely falling bodies, this is, as well as vertically projected bodies, usually you guys will follow a rule that for a freely falling body, A is equal to, you will keep plus G, and U is equal to 0. Then you will write the standard kinematic equations. What are they? V is equal to U plus AT. Next, S is equal to UT plus half AT square. Next, V square minus U square is equal to 2AS. Of course, one more is also there, Sn, but it is a special case of S. Anyway, let's write this also. Okay, this is Sn. So these are the standard kinematic equations. So when Writing the general equations here, what shall you people will do is you follow this one, and you will write down the first one as v is equal to gt, and the second equation as, and even you replace with s is equal to h, no, so h is equal to half gt square, because u is 0 everywhere, and v square is equal to 2gh. Of course this is okay, you write it. Sn is equal to g by 2 into 2n minus 1, right? So the like this you will write usually, is it or not? Yeah, this is the style, this is a method you have learnt in your schooling as well as in your board preparation also. And for projected body, what shall you do? You will take a is equal to minus g, right, and you will replace s with h. Then you write all the equations as like this: v is equal to u minus gt. Next, h is equal to ut minus half gt square, and v square minus u square is equal to 2as. Next, Sn is equal to u minus g by 2 into 2n minus 1. So this all you were already habituated in writing down the general equations for vertically projected body as well as freely falling body. And basing on this information, you will even start solving the numericals. Is it or not? But here there is small misconception which many of the students didn't knew it also. Because of that small misconceptions, they will do unknowingly mistake in problem solving, especially when the problems related to, right, when the problems related to projection from top of a tower will be asked. This is okay, this idea like up to freely falling body, projected body is okay, till here it is fine. But suppose if you take, right, projection from top of a tower like this, this is freely falling body and vertically projected is okay. But if you take a special case, that is projection from top of a tower, here many people will go wrong only due to sign convention. Even in 2023 you had a PYQ on this directly, formula based question given in 2023 basing on this concept, projection from top of a tower. Many students will commit mistake in this kind of topics because of not having a proper analysis about sign convention. That's why while solving the problems related to motion under gravity, you need to understand in a better way about sign convention. Right, let's go back. Here up to here fine. If you believe this as the idea for solving problems related to freely falling vertically projected is okay. But if you take this one, projection from top of a tower, with the help of the previous sign convention you can't solve the numericals. Because guys, the misconception in this is taking A is equal to plus G. This is the misconception, and it's always, I say that, wrong. This is not even what do you say, suggestible also to remember like this. A is equal to plus G means according to the physics you are giving the direction of gravity in upward means you are just unknowingly sharing a information that earth will also have the repulsive power. Means if you keep a object like this, it get repelled away from the earth space, which couldn't possible. Everything will be attracted vertically downward. So all the time, whether it is freely falling body, projected body, doesn't matter. Every time A must be taken minus G, you must erase this idea from your mind. As long as if you depend on this concept for freely falling body, then definitely at some point you will commit mistakes in the numericals related to motion under gravity. This is only the misconception, because just for writing these equations in a simplest way, only to write these equations in a simplest way, this will be taught to you. But actually G will never be negative. All the vectors pointing vertically downward usually taken as negative, and vectors pointing vertically upward usually taken as positive. So G will never act upward. The direction of G, acceleration due to gravity, it always acts vertically downward toward the center of the earth. Whether the body is projected upward or downward doesn't matter. Okay. So what I suggest you guys is, for solving problems related to motion under gravity, first you need to change this from your mind. You have to erase this one and keep A is equal to minus G. Then you might be getting a doubt. If you keep A is equal to minus G, you are going to get all the equations wrong. But it won't happen. The moment when you keep A is equal to minus G, you are supposed to take, I'll show in the next slide. See, if you take for a freely falling body, I'm taking here freely falling body. In case of freely falling, if you keep A is equal to minus G, then even if you have to keep S is equal to minus H also, and you have to keep U is equal to 0, no problem, but V is equal to negative. Because guys, in the physics, when you are discussing about vector physical quantities, you must follow a standard sign convention where pointing vertically upward, any vector pointing vertically upward is taken as plus, downward is taken as minus, horizontally right is plus, horizontally left is minus. Not only in the kinematics, in any chapter, when you are doing problems related to especially vector physical quantities like electric field, gravitational field, force, momentum, etc., you must follow this standard sign convention. Means vectors pointing upward always take it as plus, vectors pointing downward always take it as minus, and vectors pointing horizontally right take it as plus, horizontally left take it as minus, right? So now, with the help of this sign convention, this is for horizontal motion, this is for vertical motion. If a body is dropped from certain height, from here if a body is released or dropped, then no doubt we keep U is equal to 0, and after that you just focus all parameters are coming downward. So since downward vector physical quantities are taken as negative, S will be negative, V will be negative, right, and A will be negative. So you have to give technically this kind of thing. Of course, by taking A is equal to plus G, you can write down equations easily, but your job is not getting done only writing down the equations, no. Only with writing equations, your job is not getting done. You need to apply it and you need to solve various kinds of numericals. There, you have to make use of a standard sign convention. That's why I personally strongly suggest you to depend on this kind of information related to freely falling body. A is equal to minus G, S is equal to minus H, U is equal to 0, V is negative. Then if you take V is equal to U plus AT, right, you see. Here V is equal to U plus AT will become what as per the sign convention? Minus V is equal to 0 minus GT. Now you got V is equal to GT only. Check it out. Same information, same output will come. Same output. But you need to even concentrate sign convention for remaining areas. Of course, velocity and displacement are the parameters where always need to be substituted with sign convention. Whether it is horizontal motion, vertical motion, anything. Even you take projectile motion or motion of a charged particle in magnetic field, electric field anywhere, as long as motion is considered, the velocity displacement are always substituted with sign convention. Otherwise you can't get the accurate result, exact result. So similarly, if you take this one, s is equal to ut plus half at square, guys, you just go ahead, same result will come, no change at all, same result. Minus get cancel on both sides here. Minus h is equal to minus half gt square. After cancelling minus, you will be getting half gt square. This is the thing happens, guys. This is technically, you need to write down the equations. And v square minus u square is equal to 2as, no. So here you can write v square minus, anyway by doing square minus will become plus, no. So that is equal to here 2 into minus g and minus h. Automatically minus into minus becomes plus, and v square is equal to 2gh. Exactly the same equations, guys. Just by keeping a is equal plus g, s is equal plus h, whatever the equations you are getting, same equations will come. But what I want to conclude here is, writing down a is equal plus g, s is equal to h for freely falling body, technically wrong. Since it is a high weightage topic, this kind of small areas you need to learn even in a better way, so that your accuracy of attempting question increases. So since you are repeaters, you are going to take care of this kind of little things. Otherwise in overlook, again problems will go wrong, right? Next, let us take this topic, projection from top of a tower. I'll give you some very important areas related to this projection from top of a tower. Unknowingly, many students will ignore this topic, and whenever question comes basing on this, they will simply apply the rules related to vertical projection, and they will start solving these questions. Obviously at some point it goes wrong, so you have to treat this as a separate area, right? Okay, guys, up to now we have seen the importance of sign convention and how the students are doing a mistake in overlook by not understanding sign convention in a better way. The problem is not with the students, right from schooling itself. I think in the 9th it used to be introduced. There only the teachers will teach the same thing, and even in board also same thing. But there the requirement is only writing down the equations, not solving the problems. For writing down the equations, you can follow that sign convention, no worries at all. But here in the NEET examination, after writing down the equation, with the help of that information, you need to even do the applications. You even need to solve the numericals, where you get technically some error. Okay, so after overcoming that, come back to here, projection from top of a tower. This is right, you see. Here students, listen carefully. Let us consider h is the height of the tower. I'm taking here, this is height of the tower, right? And from this height of the tower, an object is projected vertically upward with initial velocity u. Let this point be A. From point A, an object is projecting, right? Here object is projecting with right. What happened? It's not getting rubbing, right? So okay, here an object is projecting with initial velocity u, so that it is rising certain height and then falling at the bottom of the tower. Let us consider this is the bottom of the tower. Okay, so now this is h, this is A, and this is B. Now here usually many students, what they do is, if you were asked, suppose h is given, u is given, usually if you were asked to find out time taken by the body to reach the ground, then majority of the students will depend on this formula s is equal to ut plus half at square. Since it is vertically projected, they will take a is equal to minus g, s is equal to h, and they will do like this, ut minus half gt square. They will apply this and they will solve for time. This is a misconception. Usually many students will go like this. Here the situation is, guys, height of the tower is given, next body projected u is given. Suppose if h comma u were given, and if you were asked to find out the time taken by the body to reach the bottom of the tower, then you follow this, h is equal to ut minus half gt square. But again you will go wrong because of sign convention. Here you must depend on sign convention to write down the general equation here. If you assume this situation, just focus here. This is the initial point, this is a final point. So the body has traveled initial to final like this, right? Vertically downward. Displacement is the shortest distance between 2 points, no? Even though it is projected vertically upward, reached over here and coming back, after coming here, displacement becomes 0. Initial and final points are coinciding, and then it is going traveling down. So all the time displacement is defined as the shortest distance between initial and final point. Therefore here in this case displacement is minus h. Like this you need to take. Since projected vertically upward, many people will take s is equal to h. So in this, taking s is equal to h is misconception. Thinking that vertically projected upward we take s is equal to h, but that is only body projected vertically upward and reached the point of projection. When the body went up and reached the point of projection, there you can take while going up s is equal to plus h. But here not like that, it is projected here, went up and reaching the bottom of the tower. Therefore you will take like this, s is equal to minus h. Right? Now see, if you take s is equal to minus h and a is equal to minus g, then what happens to this equation? Check it. Minus h is equal to, of course u is plus, u is projected vertically upward initially, so u is positive here, it is projected vertically upward. So this is ut minus half gt square. So like this you need to take the equation. You just take ut minus half gt square, right, and take minus inside if you want. Then you will write like this, h is equal to minus ut plus half gt square. This is a formula you are supposed to use while solving the numericals related to projection from top of a tower. And even in 2023 PYQ question has given basing on this. I think a body is projected from a bridge, it seems, vertically upward from the corner of a bridge, so that the stone rised the maximum height and reached the water. Below the bridge water is there, right? So there height of the bridge asked, h is asked, h was asked there, t given, u given, everything given, h was asked. Then the many people went on taking this equation, thinking that it is a vertically projected body. So many people did it wrong in 2023 Neet. But you have to select this equation. This is the importance of sign convention, right? And let us see some extra information related to this projection from top of a tower, so that this topic will get complete and you can do the numericals related to motion under gravity without any misconceptions. After writing down the equation, you must check the sign convention, so that you will never go wrong in the motion under gravity. Of course, you need to even do simplification also, correct? If you are really committing mistake in the simplification, you need to develop the numerical ability, problem, that is the mathematical ability you need to develop. Because in physics, identifying the concept, applying the concept, and after that, if you identify the right concept, applying after right formula, If you really go wrong in the simplification, that situation was really too not imaginable, unimaginable situation, right? You must develop mathematical ability, that basic simple calculations, right? So ut plus of this you need to use. Let us take one small application related to this, students. Take a small application related to projection from top of a tower, where I am considering three different situations over here. So this is a tower of height h I am taking, guys, projected vertical upward with initial velocity u, so that it raised certain height and reached the bottom of the tower. This is point A and this is point B you take. This is a one case I am taking. And in the second case, what I am doing is, I am considering a different situation from the same tower. This is point A. Again, sorry. In the second case, what happened is, right, in the second case, let us imagine from the same point, the body is projected downward with speed v, u, so that it reached the bottom of the tower. Listen, students, this is a case one where body projected vertically upward, so that it is reaching the bottom of the tower after doing this path. Okay, right. Next, and in this case, it is just projected downward. This is not freely dropped. It is projected downward with speed u. And in the third case, let us consider it is just dropped, not projected, from the same point, same body, so that after some time, let's consider reached the bottom of the tower. Now let's consider in all the three cases, time taken here is equal to take t1, time taken here is equal to take t2, time taken here is equal to t3. Now again, one more PYQ is identifying the relation between t1, t2, t3. Of course, it is a formula, but before remembering the formula, it is better to see the derivation also. In physics, you shouldn't only memorize the formula. Of course, remembering the formula, memorizing the formula definitely saves your time in the exam. But meanwhile, you need to have a basic idea about its derivation also. Sometimes there are chances of getting a question from the process of derivation. Okay, from middle of the derivation, there are chances of getting a question. That's why. For every formula, you need to know at least some relative information about the derivation, right? That's why here I'll show the derivation. Finally, whatever the result you will get, that you can remember. Because if a question comes on this, you may be getting direct, right? So now see, projected downward and dropped. In all the three cases, one common point is time taken is different. Why? Because projected upward, reached bottom after time t1. Here projected downward, reached the same point. Here just dropped. Dropped in the sense u is equal to 0 you will take. This is the meaning of dropped, right? So in all the three cases, the common point is h is common. In all the three cases, the displacement attained by the body is h. Listen, projected upward, reached bottom. Dropped downward, reached bottom. AB is common. In all the three cases, displacement attained by the body is same. Okay. But time taken is different. Displacement attained is same, but time taken is different. So that's why we will be asked to find out the relation between T1, T2, T3. Sometimes you will be asked to find U also. It's okay. And sometimes H also. So let's see the different variations here. But for understanding all the variations, the basic idea of derivation is necessary. So see here in this situation, okay, this is, here we can write H is equal to minus U T1 plus half G T1 square. It is projection from top of a tower just before we have seen now in the right. Here we have seen h is equal to minus ut plus half gt square. If a body projected from top of a tower, keep in mind that after reaching the bottom, displacement covered is minus ut plus half gt square, not ut minus half gt square. It is not ud minus half gt square, guys. This important. Basing on that, I have taken this one. Take this as the first equation. Try to take this second content, second information you take. So here, this is projected vertically downward. Now you will take like this. H is equal to ut, u is plus half gt square. This is the thing you will get. When u is not equal to 0, projected vertically downward, this you will take it as second equation. And this is freely falling now. So you can take h is equal to, but here t2, here t1. H is equal to half g t3 square. So this is the third equation. Right. Take all the three, guys. In all the three situations, time is different. That's why you are getting different equations, but ultimately displacement is same. Displacement covered by the body in all the three cases is same, right? Now simply we can write here 1 is equal to 2 is equal to 3. Okay, you'll take 1 and 2 and 3 are same. So let's solve it with the help of this idea. Now I'm taking first is equal to 2. This is the first I'm taking. First is equal to, this is first, this is second. No, that is minus ut1 plus half gt1 square equal to, second equation is ut2 plus half gt2 square you can write. Okay, now you bring this to this side and take this to that side, then simplify it. Half g, meanwhile we can take common. See, here take this to that side and meanwhile take half g common, so that you will be getting t1 square minus t2 square. That's it. Already t1 square is there. Take this to that side, it becomes minus, equal to ut2. No, ut2 we are keeping here itself and just shift ut1 to this side. Minus becomes plus, again ut1. So this is half g into, it is in the form of a square minus b square. You can write down it as a plus b into a minus b. That is t1 plus t2 into t1 minus t2. This is equal to, you can take u common. So you will be getting t1 plus t2. So you can cancel t1 plus t2 on both sides. Now g by 2 into, this is, you can write g by 2 into t1 minus t2 is equal to u. Or else you can write even this as, finally u is equal to g by 2 into t1 minus t2. Very important. Sometimes in this case you will be asked to calculate u also by giving t1 and t2. If you are asked to calculate u, only two situations will be given, not third. Third is not at all required. So like this situation can be imagined, visualized. Body projected upward, so that reached the bottom of the tower after time t1. Then body projected downward, reached the bottom of the time after time t2. Then you will be asked what could be u value. If t1, t2 and h head of the tower were given, then u value can be calculated in this way. G by 2 into t1 minus t2. Right, that is one of the observations. And again we need to, my motto of taking this situation is to write down the relation between t1, t2, t3. In that process you got u. Just before I told, few minutes before I told that, sometimes you may be asked questions from the process of derivation. That's why along with remembering the formula, you need to even have some basic idea about process of derivation. So right, take the next thing, that is by equating either 2 is equal to 3, right, or 1 is equal to 3. Anything is okay. My motto is to find out relation between T1, T2, T3. So somehow I need to involve T3 here. By equating 1 is equal to 2, you will get relation only in terms of T1, T2. You got this one already. Then by equating 2 is equal to 3 or 1 is equal to 3, anything you can take, right? You will get the relation between T1, T2, T3. So now try to write down it. Here I am taking, see, this UT1. UT1 minus UT1 plus half GT1 square is equal to, I want to take this. This is half G T3 square, right? Focus on this, students. Minus UT1 plus half GT1 square is equal to half G T3 square, right? Okay. So just focus here. Now substitute the value of u over here. Then minus u into, I want to take sorry, u only I need to replace now. So now minus, that is minus T1 into, right? U is equal to, we got G by 2 into T1 minus T2 na. So better you do like this. 1 second, guys. We need some more space here. Better shift this side. Okay. Now see. Here minus T1 into, in place of u I am replacing G by 2 into, right, this value I am taking, guys, T1 minus T2 is equal plus half G T1 square is equal to half G T3 square, right? Here by equating 1 is equal to 3, this I have applied, this I have taken. Anyway, even you can take 2 is equal to 3 also, no matter, whatever it may be, right? Only this is just simplification. Now on both sides you can cancel G by 2. Here G by 2, G by 2 and G by 2. So that multiply this minus T1 square minus into this, minus into minus plus T1 T2, right, is equal to, next here one more thing is left. This is plus T1 square is equal to, you will write T3 square. So this and this get cancelled. Finally T3 square is equal to, you are getting T1 T2 and T3 is equal to under root T1 T2. Very important. Actually I took this application only to show you this relation. Even in previous JEE mains also, I think once or twice problem related to this concept has given. T3 is equal to T1 T2. So T3 is the time taken for freely falling, no? T1 is time taken when projected upward. T2 is the time taken when projected vertically downward. If you are asked how the three are related, means this is the information. T3 is equal to T1 T2. Right. So now here, in the same situation, if you take height of the tower half G T3 square, you can write height of the tower is equal to, third case where the body is dropped freely, na? U is equal to 0. From here the body just dropped freely so that it is reaching the bottom, H after time T3. But just before we have seen that T3 is equal to under root T1 T2, which gives T3 square as T1 T2. By taking all this, H is equal to, you will write half G T1 T2. That's it. This is the situation. Half G T1 T2. This is H. Over. If you are asked in this situation height of the tower, this will be the formula, half G T1 T2. It's okay. This is the case, very very important. And here obviously need to remember the formula, because guys, suppose if you were given only two situations, like body projected vertically upward reached the bottom after time t1, and body projected downward reached here after time t2, and this is h and h, and you are asked what is h value, then third thing you need to imagine and you need to take this, right? Now, of course, okay, these three approaches are okay. Like remembering this, t3 is equal to under root t1 t2, and remembering this, height of the tower is equal half g into t1 t2, and u is equal to g by 2 into t1 minus t2. Somehow the problems related to this application can be managed, but what I told in the beginning of this topic, you need to remember even derivation also. You have to practice 2 or 3 times the derivation, so that remembering formula okay, but without any logic, without any derivational idea, if you remember directly the formula, no use in the physics. Definitely, even though questions are coming as easy to moderate, tricky will be involved in that. Some unknown logic, some diverting logic. Okay, students usually have some misconception in some areas, so such kind of diverging logics will be applicable. So right, so now I guess as far as motion under gravity is concerned, freely falling projected body is a very important topic, and that too consistently the question is coming from this topic, either directly or indirectly. Right students, so I suggest in motion in a straight line to begin revision with motion under gravity. After that, uniform motion and remaining problems you can take, that is horizontal motion, that all you can do. But ultimately motion in a straight line, you are getting 2-3 questions compulsory. So high weightage topic guys, and in the tomorrow session we'll come up with a new topic. Mostly I'm planning to take pseudo force. There are questions indirectly giving from pseudo force in the Newton laws, so that many people are not doing those questions up to the mark. So tomorrow's topic is pseudo force guys, right? And in the next 2-3 weeks, as I told in the starting of the class, I'm going to take some necessary information related to the physics, right, which will give you confidence and which will overcome any kind of phobia in physics. Okay guys, thanks for attending the class. Good day, bye. Close chadam. 1 second, I will join.